Hello dear students, this is Mr. Ezzat Muhammad. Today I will introduce a lesson about forces and motion. This is work for Cambridge Ordinary Level Physics. So before I get started, I want you to know that our syllabus consists of first, forces and motion. We are going to study here speed, velocity, change in speed, which we call it acceleration, the difference between distance and displacement, and other topics. Second, we are going to study electricity, then waves, energy, resources and energy transfer, solids, liquids and gases. We are going to study density and pressure, change of state of matter, and ideal gas molecules, magnetism and electromagnetism, particles, and finally we are going to study astrophysics. Okay, now we are going to start with forces and motion. The first thing we are going to learn is the definition of speed and definition of velocity. Okay, what is speed? Speed is distance per time taken. Distance per time taken. This is speed. This is something you should keep in mind. The definition of speed: distance per time taken. If you wanted to calculate speed, we use this blank formula: V equals S over T. Velocity equal distance over time. Take a look to the following example. If I wanted to calculate the speed of this man, that takes 3 seconds to move 10 meters. Okay, first I will write my blank formula: V equals S over T. Second, I will substitute in this blank formula. First, distance equals 10 meters over 3 seconds, which equal 3.3. And don't forget the unit of velocity, which is meters per second. Speaking of larger speeds, we are using a different measuring unit, which is kilometers per hour. So for larger velocity or larger speeds, we are using kilometers per hour. For small speeds, we are using meters per second. So speed is distance per time taken. Blank formula used to calculate speed is V equals distance over time. Distance is simplified to S, time is simplified to T. Measuring units: for small speed, meters per second; for larger speeds, kilometers per hour. Okay. We have here some units of physical quantities. First, unit of mass is kilogram or gram. Unit of distance is meter. Unit of speed or velocity is meters per second, as we was saying, or kilometers per hour. Unit of acceleration, meters per second square. This is something you should keep in mind. You should memorize this. unit of forces, newtons, unit of time, second, gravitational acceleration, newton per kilogram, which is simplified to n over kilogram, unit of momentum, kilogram times meters per second. Okay, let's move on to the other part. So the other part is talking about or revolving around the difference between distance and displacement. What is distance? Distance is the change of position of an object. The change of position of an object. Take a look at the following example. Imagine we have a man moves on this road. This road isn't straight road. Okay, we call the change of position in this case as a distance, because it isn't straight road. Okay, if it's straight road, we called it displacement. So the difference between displacement and distance, that distance isn't a straight road, or a straight line. Displacement always a straight line from the starting point to the end. So distance, the change of position of an object, and always isn't a straight line. Displacement, the change of position of an object, and always a straight line. So distance always isn't a straight line. Displacement is a straight line always from the starting point to the end. The unit we are using to measure distance is meters. The same unit we are using to measure displacement, always meters. But here you have to write the direction, because displacement is a is a vector quantity. You should write the direction. The direction here maybe 5 meters to the north. Here, or at the distance, we write about 50 meters, and we don't have to write any direction, because distance is a vector quantity, is not vector quantity, scalar quantity. Distance is a scalar quantity, displacement is a vector quantity. Again, the change between, or the difference between distance and displacement is that distance isn't a straight line and is a scalar physical quantity. Displacement is always a straight line from the beginning to the end, and is a vector quantity, and both are measured with meters. Okay, take a look at this example. From C to D, the straight line, or the straight distance, the red line, we will name it displacement. Okay, straight line, and always a vector quantity. The blue line represents the distance. Why? Because it not a straight line. So this is difference between displacement and distance. Straight line, not straight line. Vector quantity, scalar quantity. Okay, this is distance time graph. Distance time graph, its slope always equal velocity. So if I see distance and time, its slope always equal velocity. To calculate the slope from this figure, I will divide 3 over 3. 3 for distance and 3 for times to calculate velocity. So velocity equals 3 over 3, which equals or gives us 1 meters per second, and don't forget the unit. So in distance time graph, the slope always is going to be velocity. Velocity equals to distance over time. And don't forget to write your unit. We have something that we name it average speed. What is average speed? Average speed is total time, total distance traveled, total distance over total time. To understand this blank formula, I want you to take a look to the following example. Imagine we have a man moving, not at rest, at the second one, from the first second, he moves 1 meters. Second, he moves 2 meters. Third, he moves 3 meters. 4 meters. I want to calculate or find average speed for this man. Okay, first of all, I will write my blank formula. What is my blank formula? My blank formula is average speed equals total distance over total time. Okay, I write my blank formula. Then I will substitute in this formula. Okay. Total distance 1 plus 2 plus 3 plus 4 equals 3, 6 equals 10. Average speed, we simplified it to V dash equals total distance 1 plus 2 plus 3 plus 4 equals 10 meters over 1 plus 2 plus 3 plus 4 equals 10 seconds. That gives us 1 meters per second. This is the average speed for the man. So average speed, by the way, in this case equals to normal speed. Let's move on to the other part. This is some explanations of motion from graph. Okay. The first, distance and the time always gives us v. H slope always gives us v. Okay. The kind of velocity here or speed here is that speed increases. Speed in a straight line that crossing the point 0.0. In this case, velocity or speed increases. The second graph, distance and the time, always gives us velocity. The kind of velocity here, if we notice that at 1 second the distance is 0, 2 seconds distance also 0, 3 seconds distance also 0. That means this body or this object isn't moving. This object isn't moving. This object at rest. So, represented graphically as a straight line parallel to horizontal axis. Straight line parallel to horizontal axis. The third figure, or the distance and the time, always gives us velocity. This in this case speed increases, but the rate of increases isn't equals the rate of increases in the first figure, which we name it in regular speed, which name it irregular speed. The first figure is regular speed. The third figure is irregular speed. Zero display the force or graph number 4, horizontal straight line parallel to horizontal axis. This object is not moving. The same in the second case. In this graph, distance and the time, slope is v, and v in this case is the acceleration or the decelerate. This is the average speed equals distance moved over time taken. Speed is defined as the rate of change of distance, as we were saying. To calculate average speed, we use average speed is a total distance moved divided by total time taken, and we took an example to calculate how to calculate average speed. I want you to know what is instantaneous speed. Instantaneous speed, the speed of an object at a particular moment is called instantaneous speed. The speed of an object at a particular moment. The difference between speed and velocity. Okay, this is an important, you should know. Speed is the rate of distance traveled, can be at in any direction. Speed is a scalar quantity. Velocity, rate of change of displacement. Rate of change of displacement, we call it velocity. Velocity is speed in a particle direction, north or south, east to west, and etc. Velocity is a vector quantity, needs a direction and magnitude, both direction and the magnitude, d plus m. But speed just need magnitude to be defined. This is an experiment. To calculate velocity and displacement. Let's move on to the other part, which is talking or revolving around the acceleration. What is acceleration? Acceleration is rate of change in speed. Rate of change in speed. Okay, the blank formula we are using to find acceleration: A equals delta V divided by delta T. Delta V equals final velocity subtract from initial velocity divided by time. So we use this blank formula to calculate acceleration. Delta V over delta T. Delta V equals final velocity subtract from initial velocity divided by time. And acceleration is defined as rate of change in speed. Rate of change in speed. Rate of change in distance is speed. Rate of change in displacement is velocity. This is something you should keep in mind. Okay. I will take an example to acceleration. I want you to calculate the acceleration of this car. One second. Speed of is 2 meters per second. 2 seconds speed of 7 meters per second. 3 seconds speed is 10 meters per second. First, I will write my blank formula. A equals delta V over delta T, which equals final velocity subtract from initial velocity over time. So I will substitute in. I will substitute in the blank formula. Final velocity, which is 10, subtract from 7 initial velocity over time taken. From third second to the second, which equals 1 second. 10 subtract from 7 equals 3 over 1 equals 3, and the unit we are using to measure acceleration is meters per second square. So in this case, acceleration equals 3 meters per second square. That's all for today. See you in the next lesson.